Hey guys, in the previous video lesson we learned how to add and subtract vectors when they are given on the same axis. In this video lesson we would learn how to add and subtract vectors when they are not given on the same axis. Let's understand this with an example. If we're given a vector A 3 cm north and we're given vector B 2 cm west. How do we draw vector A? Because it's 3 cm north. So let's say this is vector A. Vector B is 2 cm west. So this is how it looks like. Now if you're supposed to add vector A and B, we'll follow the same rule. That is, the head of A will join to the tail of B because A is the first vector. So how do we draw the sum of these two vectors is, we'll first make vector A, so this is our vector A, and we'll join vector B to the head of vector A, and this looks like this. Now the sum of A and B is always from the start point of the first vector, that is A, to the final point of the second vector. So this is our resultant, and this will represent vector A plus B. Now in this case we see we cannot just simply add A and B as we did in the previous video, because these two are not in the same direction and this vector lies on a different direction as these two vectors. So we'll just see what this forms, and we see this forms a triangle. This is called triangle law of vector addition. So we saw that whenever the two vectors are not in the same axes and we join them from head to tail, we get what is called as the triangle. And we use triangle law of vector addition for adding these two vectors. So we'll see first what type of triangle this looks like, and this is a right angle triangle. Now if you want to find out the resultant of the right angle triangle, this resultant is nothing but the hypotenuse of the triangle. So we would just follow Pythagorean theorem, and that would be square of vector A's magnitude, square of vector B's magnitude, and square root of this entire sum. This would give us A plus B vector magnitude, means just the numerical value we would get. So we are given the numerical value of vector A is 3 centimeters. We are given the numerical value of vector B is 2 centimeters, and we'll do square root of it. 9 plus 4 square root is 13. So A plus B vector, just the magnitude, is square root 13 centimeter. Now we know whenever we have to write on a vector, we also have to describe the direction, and the direction comes here. And this vector has a direction going this way. So whenever you're looking for a direction, you're looking for an angle theta, and the angle theta forms between the first vector, that is vector A in this case, and the resultant vector. So this is the first vector and this is the resultant vector. So this is theta angle. Now in order to find out what is this angle theta, we know this is 2, we know this is 3. So we can use tan theta ratio, and we can do that here. So tan theta is equal to opposite is B over adjacent is A. So B is 2 over 3. That is equal to tan theta. Theta will be equal to tan inverse of 2 over 3. That gives us 33.69, or if you want to round it up, we can just say 34 degrees. Now how do we write it down here? So we would see this angle lies between which axes? This angle lies between north and west axes, and it is joining the north side. So we would put north first, then we'll put 34 degrees, and then we would put in west. So this is how we represent the full vector with the angle. And when we mention this angle, then we can take these bars off, because now it is the entire vector, not just the magnitude. So our final answer is vector A plus B equal to square root 13 centimeter, 34 degrees west of north. Let's take up another example. Let's say we have vector A, magnitude is 4 centimeter, direction is south 20 degrees east, and vector B is 3 centimeter, direction is south 35 degrees west. Now how would this vector look like? We can make cardinal axes. This is vector A between south and east, so would be here, and the angle is joined to south side because south comes first. This is vector A. If we want to draw vector B is between south and west, and the angle is now still joined with south because south still comes first. This is our vector B. If let's say we have to add vector B and A. If we want to draw B and A vector on axes, we'll draw the cardinal axes first. And because we have to add B and A, so B goes first, we'll make B vector first. This is our vector B. Angle is joined to south, which is 35 degrees. Wherever B finishes off, there we have to start vector A. So vector A's tail is going to join to the head of vector B. So just to make it easier, we can make another cardinal axis joining the head of vector B, and from here this is turning around in southeast direction. So this is south and this is east direction of the new cardinal axis. So it turns around southeast, making an angle of 20 degrees to the south. And this is our vector A. Then the resultant of B and A will start at the origin of B or the tail of B and would end at the head of A, and this forms the triangle. Therefore, we are going to use the triangle law of vector addition. We would write down B plus A. Now we know this is not a right angle triangle. This is an acute or obtuse. This is an oblique triangle. So for oblique triangles, we use cosine or sine law for vector addition. So to find this resultant, we need this angle. Now to find out this angle, we would use our angle properties from lower grades. We know this angle is 35 degrees. So by Z pattern, this forms the Z pattern. By Z pattern, this is going to be 35 as well. This part of the angle is going to be 55. It's just this part. Because this is 20 degrees, this part of the angle will be 70 degrees. So the sum total of this angle is going to be 55 plus 70, that is 125 degrees. Now if we want to find out what is the resultant, we would use cosine law because we know this value is 3. We know this value is 4. This is the magnitude that we are looking for. So we can write on vector B plus A magnitude is square root of vector B's magnitude square plus vector A's magnitude square minus 2 times vector A times vector B magnitude cosine angle 125 degrees. Vector B is 3 square. Vector A is 4 square minus 2 times 3 times 4, and cosine 125, when we put on the calculator, we get minus 0.57. When we put this all on the calculator, we get square root of 26.68. And that is equal to 5.165, or we can just write it as 5.2 centimeters. So this is just the magnitude of B plus A, which is 5.2 centimeters. We need to find out the direction. To find out the direction, we need this angle because this is the cardinal axis and this is our vector. So we need to find out what is this angle. To find this angle, we would use sine law. And how would we use sine law is, we know this is 5.2 and the angle opposite to this is 125 degrees. We know this side is 4 and the angle opposite to it is, although we know this part is 35, but we will just consider that this whole angle is something that is unknown to us, because if this is ABC triangle, then sine law would be sine of angle A over side A, we'll take the magnitude, equal to sine of angle C over side C magnitude. So let's call B plus A as C magnitude. Now sine A is something that we are looking for. A magnitude is 4. Sine C we can find out because we know angle C is 125 degrees and C magnitude we know is 5.2. All we have to do is just cross multiply. So sine A would be equal to sine 125 degrees times 4 divided by 5.2. When we put this on the calculator, we'll get 0.63. So angle A would be equal to sine inverse of 0.63, and that gives us 39 degrees. Now we'll look at our picture. We know this part is 35, we know already, and this part is the extra 4 degrees because this total we have got is 39 degrees. So how do we write on this angle is vector b plus a is equal to 5.2 centimeters. Direction is with south and it is 4 degrees with south in between south and east. In the above two examples, we covered up triangle law of vector addition. So let's see what is parallelogram law of vector addition. So if we have vector A equal to 3 meters in east direction, vector B is 2 meters in north direction, we draw vector A in east direction and we draw vector B in north direction, and if we want to add them up using parallelogram law, the only difference between the parallelogram law and the triangle law is that in parallelogram law, we join the two vectors A and B tail to tail. So we make A first and B's tail is joined to the tail of A. So this is how it looks like. So this is vector B and the sum of these two vectors passes in between A and B. Now to find this resultant, all we have to do is just complete this as a parallelogram, and whatever is the magnitude of this, the same will be the magnitude of this opposite side. So we'll just use this to find out our resultant. So technically we are doing the same thing, but the way we are drawing it is called a parallelogram. So if we are drawing it this way, we will use parallelogram law of vector addition. And now A and B sum is still going to make it look like a triangle, which is a right angle triangle. So A and B magnitude square root will give us AB sum magnitude. And we can use the same method of addition, that is Pythagorean theorem. Then we can use tan theta to find out angle theta. Let's go over vector subtraction now. Math part of vector subtraction or addition using triangle law or parallelogram law stays the same. Only the way of drawing is different. So if we have vector A equal to 3 meters east and vector B is equal to 2 meters south, we know vector A is drawn like this, vector B is going to look like this, and if we have to subtract them, we have to take the negative of vector B, that will look like this, and we'll just add A and negative of B. So these are the two vectors that we'll be taking consideration of. So we'll draw vector A first, and with the head of vector A, we'll join the tail of vector negative B. This resultant is called A minus B. Math part stays the same because this is our resultant and this is a right angle triangle. So the magnitude of A is going to be equal to 3, magnitude of B is going to be equal to 2. And we'll use Pythagorean theorem for it. Vector A minus vector B magnitude is going to be equal to square root of vector A magnitude square plus vector B magnitude square. And when we solve it, we get 3 square plus 2 square, square root of it, 9 plus 4, which is square root 13. So we just saw that the magnitude is still square root 13, unit is centimeters. We'll find out the direction now. Direction is theta, so we'll use tan theta for that. Tan theta is equal to opposite over adjacent, which is 2 over 3. So theta will be equal to tan inverse of 2 over 3. That is going to give us 34 degrees. Here we got vector A minus vector B. Here we got vector A minus vector B is equal to square root 13 centimeter. With east, we have 34 degrees joint in between north. So the only thing that differs is your magnitude stays the same, but one of the vectors B was in south direction, whereas your resultant comes in east and north direction. For parallelogram law of vector subtraction, we know vector A is 3 meters east and vector B is given to us as 2 meters south, and we have to subtract, let's say, vector B minus vector A. So vector A looks like this and vector B looks like this because we have to do B minus A and we have to use parallelogram law. Parallelogram law means tail to tail joining. Triangle law means tail to head joining. So we will make vector B first. Vector B is going to be made first. Then using vector A, we would make the negative of vector A, and that is what is going to join to vector B. And how we're going to join is not the head with the tail. We're going to join the tail of vector B with the tail of vector negative A. So we are using this and we are using this. Now since we're joining tail to tail, the resultant is going to be this, and this will be called b minus a. To solve this, we would complete the parallelogram. Now the value of this b is 2. The same will go with the value on the opposite side b as well. So to find out this resultant, we would say b minus a magnitude is going to be equal to square root of b square plus a square, which is going to be equal to 2 square plus 3 square, which is 9 plus 4 square root 13. Magnitude is still the same. Only that is going to differ is the direction, and the direction is now going to be between west and south. We would use the same tan theta formula. So tan theta is going to be equal to 2 over 3, where theta is going to be 34 degrees. So now b minus a would be represented as square root 13 centimeter, and direction is theta joined west 34 degrees south. And we see here, because a was flipped, so the direction of a is flipped. Direction of b stays the same.